Hello everybody, super excited to show you the latest update of the Agentic Quant system. This is a system where you can describe a trading strategy in natural language, and a series of agents will go out and build you not only a backtest but an actual implementation of the strategy for execution in the interactive brokers, in your interactive brokers account using IB in sync. And you might be wondering, okay, that's great, I can do this with ChatGPT. Well, the problem is that ChatGPT, yes, will potentially give you something and it will probably run, but that's just about it. This does not give you any benefit of prior research, does not have any knowledge of edge. The edge is completely gone in any trained LLM. So going through this process of just typing something into ChatGPT or Claude for that matter, is a pretty bad strategy. I've been operating in a global AI consulting practice where I do agentic for Fortune 100 companies, and this is the number one failure mode for the development shops, is just assuming that the code that comes out of Claude is working. So we're going to move away from the copy and paste prompting back and forth, copying and paste coding into your IDE, only to get errors and going down these terrible rabbit holes with the tools like Cursor. We're going to move away from that. We're going to move into an agentic workflow where a series of sub-agents are doing all the work for us, and I'm going to give you the full end-to-end picture of how this works right here and right now. The best part of all this, it takes no time to get set up and get running. All you'll need is your Anthropic API key, and we are actually using VectorBT Pro in this code repo. There is also a Zipline Reloaded agentic workflow as well, but getting data into Zipline Reloaded is actually a bit of a trick. So I built it all out. I have instructions on how to work it, but VectorBT is a lot easier. In our case here, we use VectorBT Pro. It's about $20 a month, maybe $25 a month. And frankly, it's an excellent cutting edge library that you will not regret paying $25 for. There's a bit of a setup installation because it is a private repo, but once you go, you use UV to sync all the requirements. You use UV sync to get all your requirements going. So let's go into Research Agent and hit UV sync. Oops, UV sync. And UV is an awesome packaging library. That's it. Everything is installed. No more dependency issues, no more no more of this crazy dependency errors. UV takes care of it all for you. So let's run it. UV, clear this so you guys can see. Clear. UV run Python research agent. I'm actually going to show you that file in a second so you can see that I'm just running this code right here. I hit go. The agent is running. So it's asking you for a trading strategy. So I'm just going to give this an example. Develop an intraday statistical arbitrage strategy between uranium stocks. And the agent will go do its thing. So I'm going to minimize this and actually walk you through the rest of the code. So what happens? So I'm just gonna lower this so it's not a distraction, but first, intraday stat arb in uranium miners pairs back at co-integration. It's pulling out all of the keywords. It's actually describing the symbols. It's talking about co-integration tests, position sizing, benchmarks. It's doing all of this, okay? So I'm gonna minimize this while it runs and I'm gonna walk you through the code. So there's a 7-step phase. So the first thing that happens is there's a research phase. So we run 3 parallel sub-agents that go out and look at academic research, web research like blogs and on posts, and then actual code. So it's looking at Kaggle, it's looking at GitHub, etc. It takes all of this information. It looks like this. So this is the output. So this is actually an RSI sector rotation example. So this is the academic research on an RSI-based sector rotation. So paper 1, how to improve ETF sector momentum. Here's all the details of the paper. Paper 2, tactical asset allocation using relative strength. Paper 3, factor momentum and the momentum factor. We have a bunch of parameter summaries, so we're actually looking for the parameters of the strategy that are described in these academic papers, cross-paper performance summary, additional context from other additional literature review. So this is all created by the first subagent. The second subagent does something very similar. So it's out looking for content on a sector rotation strategy from the internet. So Quantpedia has some content. Pocket option has some content on this type of strategy. Quant Connect has some content, and you have here the parameters, all the posts, and some of the details about what best parameters fit. We have some pitfalls, live versus backtest notes, additional practitioners' insights, etc. So all of this is being written by the subagent that's researching the web. The third subagent is actually looking for implementation, so actual code. So Quant Connect has some code, position sizing, rebalancing. Here's a GitHub repo that has some code. Here is and then some summaries, some additional sources, etc. So those three subagents complete, and the next step is a synthesis. So the fourth subagent actually writes the synthesis of all of that research. So here is the theoretical basis, here's the description, here's details about the category, the universe components. So this is a sector rotation strategy. So these are sector-based ETFs. Here are the common strategy parameters. And in the agent itself, it's not just saying take an average or take the best. It's actually reasoning about which parameter set makes the most sense. So that's exactly what this is doing. This is not just blindly copying. It says academic literature cites this, Quantpedia uses that, but practitioners note shorter lookbacks capture recent regime changes better. So it's actually giving a justification of why each of these various parameters within the strategy makes the most sense. Okay, we've got some data requirements, entry exit conditions, entry, exit, edge case handling, position sizing. It actually has some basic code. So this is all written from the actual agent. Now, most importantly here, we have actual performance benchmarks. So later, when the backtest is run, it will compare the backtest results to the actual benchmark results. And if it doesn't pass a series of tests and validate itself, then it fails and it will not write the live trading strategy code. And that is by design. Okay, this is a huge benefit of the workflows, because you're not just going out to ChatGPT with no knowledge of how this thing works. You actually have this benchmark data. So the agent wrote this file that will be used later. Here's some implementation guidelines, data requirements. Here's the implementation pattern for Vector VT Pro, some risk considerations, overfitting risks, all sorts of different details, the sources that we used. And then if we want to do a parameter sweep, here are some ranges. All right, so we've got a synthesis. So now we're going to actually plan the backtest. So the backtest plan, this is becoming and emerging as a very, very important concept in agentic coding, which is you build a plan and then you actually write the code against the plan. Very important. So we've got the strategy summary, the core logic, performance benchmarks as we saw earlier. Here are some implementation decisions. So portfolio entry point, why are we not using the from signals method on Vector VT? Universe and benchmark data, API mapping table. So how are we actually doing the things we need to do with Vector VT? And I will show you how it knows all this in just a second. Phase by phase implementation plan. So here are the imports, loading the data, calculating the indicators, calculating the weights, portfolio construction, benchmark construction, results in comparison, validation checks. So this is what I was referring to earlier. Parameter references, final parameters, complete implementation pseudocode. So this is not necessarily executable, but it's pseudocode. And then you've got this checklist. So the agent will keep running until all the elements in that checklist are complete. All right, so we have the backtest plan. So then we write the actual backtest. So the agent will write the code for the backtest, and it actually looks like this. This is the code the agent wrote, and this, yes, this runs. I can show you that later. So we've got a function that says build signals, actually run the backtest, print the results, and it's 170 lines of code. This stuff does not have to be massive, but it's actually in a function here that you could run if you wanted. Okay. So in the test, we actually get a backtest report. So this is the full performance metrics out of the backtest. So we had a start value of 100K, and the ending value ended up at 335,000. So this is a 3.5x. Looking at the Sharp, so a 0.7 Sharp ratio. So not terrible for a sector-based momentum strategy. And this is actually the backtest set of parameters that passed our benchmarks. Okay, so here's the benchmark performance. This is just S&P buy and hold. And then we've got all of our comparisons. So what did we actually expect? So we expected something in a Sharp ratio between 0.5 and 0.8. We fell right between the middle of that. The CAGR is 8% to 12%, just slightly below the CAGR, but we're calling that acceptable. Max drawdown 30 to 50% based on the synthesis of all the research of the strategy, and we actually came in a little bit underneath. Okay, so this is all really, really important stuff in agentic coding workflows. You really need to have this type of validation, and getting the validation benchmarks is actually very difficult in a lot of circumstances. But in our case, our agents are doing that for us. And then finally, we have the plan of the implementation of interactive brokers code. So this is very similar to writing the backtest. I'm not going to go through this in terrible detail, but strategy mapping, how are we actually mapping the backtest code to the IB in sync to write the execution code, calculation indicators, it's all here. So scheduling strategy. So in our case, we are only running this on a cron, so we would actually schedule this. So you're actually getting the command to schedule that on your computer, or how to run manually, how to manage the connection, etc., 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 error handling, on and on and on. Okay, so this is running all of this stuff. Now, how does this all actually come together? Well, we've got a single Python file, which is like 100 lines of code. That is the agent orchestration. So we're using the Claude Agent SDK, and there's a reason I'm using this, and I'll explain it in a minute, for actually running the agentic workflow. So it's actually pretty simple code. You load prompts from flat files. You have this asynchronous function called chat. When it's run, you look up the Anthropic key. You load all of the agent prompts. So this is the magic that makes the agent work. You then create a so-called hook. It's a sub-agent tracker. I'll show you this in a minute. And then you define all your sub-agents. So this is specific to the Claude Agent SDK, but these are all sub-agents. So the academic researcher agent is an agent definition, the web researcher agent definition, etc., etc. You're going down and down. I've got some hooks. I'll show you what that looks like in a second. You create some options, you print some stuff, and then you run. So this is all the code that just makes the thing run, and you're done. So 190 lines of code that is actually giving you this running down here. So where are we? You're seeing these things run. So we have spawned the academic researcher that's doing web searches. We have spawned the code researcher, which is doing searches. We have the synthesizer sub-agent who is reading files and synthesizing. We have the backtest planner. We have the backtest developer. And then we have the tester. So that's where we are now. We're actually going through and testing the backtest code that we just wrote. And that corresponds to each of these separate sub-agents. So if I actually look at some of the files here, you'll see that, so this is the entire course here. I'll talk about that in a second. But you'll see in the files directory that you've got the RSI sector rotation strategy. So that's what I just showed you. And inside this directory, you have the implementation of the backtest. You have the implementation of the actual interactive brokers live trading code. This is what that looks like. So connect to interactive brokers, handle some errors, very important, obviously, fetch historical data, calculate the indicators, apply the strategy rules, get the current positions, calculate target positions, execute the rebalance, wait for fills, and then the main function that actually runs it all. So this is what the agent wrote that actually represents the strategy, but using IB in sync. And then down here are all these files that I just showed you that the sub-agents are writing as it's creating its strategy. This is the second strategy that I just ran, uranium mining statistical arbitrage, and you can see that it's halfway through. It's still writing the backtest plan. It's only got the backtest implementation so far, but it's still going through its processes. So here are all the prompts. So each sub-agent is defined by a prompt. And the kind of magic here, guys, is the so-called lead agent. So the lead agent's job is to do one thing and one thing only, which is to actually orchestrate the entire workflow. So the lead agent is an agent, and then everything else is a sub-agent. The academic researcher is a sub-agent. The backtest developer is a sub-agent. Backtest planner, backtest tester, code researcher, implementation planner, research synthesizer, strategy implementer, web researcher. These are all the actual sub-agents that are running through and doing all the work. The lead agent just orchestrates it. The other two things I want to show you, first thing I'm going to show you are the skills. So I've got 4 custom-built skills for this workflow. The first is for IB in sync. So IB in sync is a library that makes it easy to trade with interactive brokers. And the skill is here. We've got a bunch of scripts which actually show like patterns or templates for how to do certain things like place order. I'll just give you a look. So this is a simple template of what placing an order looks like, and this is all used by the skill. And then we have references. So what is a contract? Contract is. This is right out of the code itself. So this gives the agents all of the information that it needs to know about writing code for IB in sync. I've got another one for being a Python developer. This is just writing good Python. There's another one in here called strategy research. So this is where you start to get away quickly from just using, say, ChatGPT or Claude to try to write strategies from you. They don't really have this in-depth skill. So you can go in and write these specific strategy skills that tell it where to go, what to look for, etc. And then finally, the Vector BT Pro. This is quite a long one. This took a very long time, but very similar to the IB in sync. We have some references, some code references, and some scripts that allow the agents to really understand how to write code for Vector BT. Okay. The final thing I'm going to show you that's included here is the hooks. So hooks are things that will fire along certain events during the life cycle. So when a tool is called, when something is happening, this is all stuff that happens throughout the life cycle. So these hooks will fire, for example, hooks, pre-tool hook. So this will fire before a tool is used. So tracker, this sub-agent tracker, pre-tool use hook, and then post-tool use hook. So these are just arbitrary functions that run at certain events. Okay, so let's look at what we ended up with. Good timing. Our backtest validated, scripts run cleanly. The Sharp was actually a 1.98. Pretty good. This exceeds the target of 0.8 to 1.5, max drawdown 5.6%, much better than the expectation. So it does find that there was a critical, so it's saying critical, these two symbols are not actually co-integrated. It's got a p-value of 0.389. That's probably okay if we're getting a Sharp ratio of 1.98. That said, we do have the backtest written, and I didn't mention earlier that the backtest tester will run 6 times. It runs 3 times to check for syntax, and it will fix the syntax, and then it runs 3 times to attempt to tweak the strategy parameters to meet the benchmark. Okay, so all very, very sophisticated stuff, all baked into this system. All of this code is yours in the course. And the way that I broke this out is that in the course itself, there's 8 modules, and each module builds on itself. So the very first module, you have a very basic agent. Really, all you have is 4 subagents and a simple script that ties it all together. And by the end, you're running exactly what I just showed you. So you've got the whole suite of agents, you've got the hooks, you've got the entire suite of skills, and you even have commands. So if you wanted to run the / command in Claude Code without running this whole pipeline, you can do that too. This is the entire agentic workflow. This is what comes all baked into the course, and this is all launching for you very, very soon.